back. Today we're going to start talking about our uh, section 4.7. Now, you'll notice I'm not at the beginning of these notes. Okay, so the beginning of these notes, that's kind of a warm-up for you using your unit circle. But I am going to reference this unit circle here as we talk about our inverse sine, inverse cosine, and inverse tangent. Now, here's the thing you got to remember about arc sine or inverse ratios. We're undoing some things. And so I'm actually going to come up here and I just want to kind of preface this by saying we've been doing inverse operations for a long time. If I do 3x over 3, it's obviously equal to x. And some people will say these cancel out. Well, really they undo one another. Multiplying by 3, dividing by 3 undo one another. And in essence, we cross them out. They're canceled out, but they're not canceled out. Both things happen. They just undo one another. And the same way, if I do x plus 5 and then I subtract 5, it's equal to x because adding 5 and subtracting 5 undo one another. Arc sine and sine undo one another. The inverse sine function is written as sine inverse of x, and it undoes the operation sine. Well, what does that mean? It means that we are looking for the angle whose sine is. Okay, so when I say inverse sine, I'm saying find the angle theta whose sine is x. And so what can happen? Well, if we look up here for a second, and what you were doing, if you did this, which I hope you did as a review, it says give the angle between negative pi over 2 and pi over 2 that has the given ratio. The sine is equal to 1/2. Well, when I look on my unit circle, where's my sine? Those are my y coordinates. Well, here we go. Here's one whose sine is 1/2. Here's one whose sine is 1/2. The qualifier was between negative pi over 2 and pi over 2. Well, that's pi over 6, because this one is not. So negative pi over 2 is down here to pi over 2, so the right half of the unit circle. And so the answer to this would be pi over 6. That is the angle whose sine is 1/2. That's arc sine. So using using the trig ratios in the unit circle to work backwards and find an angle based on a sine or a cosine or a tangent is arc sine. The domain of the arc sine function is -1 to 1. It's the range of the sine function because they're inverses. Whereas my range here is from negative pi over 2 to pi over 2. Okay. Inverse cosine looks like this. Cosine inverse of x. And my domain is, again, -1 to 1. And my range is from 0 to pi. Inverse tangent, tangent inverse, and my domain is -infinity to infinity because, and that should be parentheses, because the range of the tangent function is infinity. Remember that graph looks like this. It's got these things that go into infinity, and beyond. And so my range here is going to be between negative pi over 2 not included and pi over 2 also not included. Okay, and so to find values without using a calculator is using my unit circle or my knowledge or a combination of both to find these values. So here we go. The sine inverse of 1/2. If I reference this unit circle, this is the one we just did. The sine inverse of 1/2 means find the angle whose sine is 1/2. Well, it's pi over 6. And so that's equal to 30 degrees. And up here, I also found that 5 pi over 6 would work. And 5 pi over 6 has a value of 150. And so it seems to have two answers. But now that we know, and we've talked about these stipulations, my range has to be between negative pi over 2 and pi over 2. And so it's not an extraneous solution per se, but it's kind of the same concept. I have to go back and I have to consider, is the value in the range. Okay, and so over here, I'm going to make a list of things to consider or things to remember. I got to ask, is my answer in the range? Okay, is my answer in the range? And there's going to be a couple of things under here. There's going to be two things that we can do to kind of help ourselves not just evaluate that, but fix it if it's not. The other thing I need to consider right away is my x in the domain? Okay, and so they're going to try to trick us sometimes and give us a value that's not in the domain, but that's that's a consideration we've got to have. Okay, so find the following values without using a calculator. So we did that. We eliminated a solution that was not in the range. Sine inverse of negative 3 pi over 2. So I want to find where my sine is negative 3 pi over 2. So what you can kind of see now is, where do I have to look? Well, for sine, I'm only going to look over here. So where's negative 3 pi over 2 and the y value? It's right here, and that is 5 pi over 3. And so we have to consider, is that actually in my range? Okay, well, it's actually not in the range, right? Um, because it's between negative pi over 2 and pi over 2. But Mr. Saris, you just said that for the inverse sine, it's the right side of the unit circle. And I'm going to put an ellipsis there because, yes, it is, but it's between negative pi over 2 and pi over 2. So what I have to consider is that this is pi over 2, this is 3 pi over 2, but it's not really what we're considering. This is actually negative pi over 2, or negative 90. Okay? And so, yeah, this is 5 pi over 3. It's 300 degrees, but I need the coterminal angles with those that are equivalent to them. And so instead of saying 330, this is negative pi over 6, or negative 30. Why do I have to say that? Because my range of my sine inverse function is from negative 90 to 90. And in the same way, instead of this being 315, this is negative 45, or negative pi over 4. And so, yes, it's coterminal, so it's technically the same thing, but in order for it to be considered in the answer, you can't write it like this. It's got to be negative pi over 3, or negative 60. Okay, it can't be, you can't write it as 300. You got to write it as negative 60. Okay, and so over here, is my answer in the range? If you get no, then you need to rewrite it as a coterminal angle in the range. Okay, so what I did was I found this, and it wasn't technically the wrong answer, but it couldn't be the right answer because it was in the range. So I had to rewrite it as a coterminal angle in the range. Okay, sine inverse of pi over 2. Okay, so where is my sine pi over 2? So where's my y coordinate pi over 2? Not at pi over 2. Where is the sine pi over 2? Nowhere. I don't see it on here. So does it exist? Well, you got to think. Pi over 2 is roughly equal to 3.14 over 2, which is roughly equal to 1.57. Okay, well, that's not in my domain. Okay, my domain, so this does not exist because this is not in the domain. 1.57 is not in my domain. And so right there, I've used three of these things. Is my answer in the range? For the first one, it wasn't. If my answer wasn't in the range, I could rewrite it. And sometimes x isn't in the domain. What I'm trying to find isn't in my domain. Let's do three more. Here, I just told you they undo one another, right? So sine inverse and sine undo one another. Okay, so this right here, pi over 9, works. It's in the range, right? It works. It's good. This is a good thing. But when I consider e here, what's got to happen? I'm going to work from it inside out. My sine of 5 pi over 6. Check it out. Let's go to 5 pi over 6. 5 pi over 6. My sine is a half. So this is a half. And my sine inverse of a half is equal to, so you see what I'm doing here? Sine inverse of a half is pi over 6. Whoa, Mr. Saris, you just told me over here that they cancel out. Well, think about what happens if I cancel out here, right? If I cancel these out, I've got this 5 pi over 6. Well, look, it's exactly what happened up here. I ended up with two solutions, and one of them wasn't true. So this one, how's it related? I had to find the angle whose sine was a half, but it was over on the left side here, right? And so to get the right answer, I had to reflect it across to get a coterminal angle. Nope, not coterminal. To get an angle with the same reference triangle. So the other thing that could happen is my answer is not in the range. So this was 5 pi over 6. This is not in range. Okay, that was not in the range. However, pi over 6 is reflected reference triangle. Okay, so the other thing that could happen is if my answer is not in the range, is there a reference triangle? So I use reference triangles to find a reflection. Okay, so that could also happen. Here, let's talk about cosine. I'm looking for the x coordinate that's negative 3 pi over 2. I don't see it. I don't see it. Well, wait a minute. Here's a cosine of negative 3 pi over 2. So this is 5 pi over 6. Is that true? Is that in the range? So I did 5 sine examples. Now I'm doing a cosine example. So check out your range. It's 0 to pi. Is 5 pi over 6 and 0 to pi? Yes, we're good there. Okay? So that's how that works. Okay? So check your domain. Make sure it's in your domain. Then check to see if you're answering your range. If it's not in the range, you have to do one of two things. Either you have to rewrite it as we did in B here. You know, rewrite it instead of 5 pi over 3, I wrote it as negative pi over 3. Or I could reflect it across like I did here in E and A and said, okay, the sine is 1/2 here and here, so if it can't be 150, it must be the pi over 6. Last one. Geometry throwback here. To find angle measures, find the indicated angle in degrees. This is a note for your calculator. To find this, think about my angle here. I've got this right triangle. It doesn't particularly look right, but it's marked that way. I have my adjacent and I have my hypotenuse. This is my opposite. If I have adjacent and hypotenuse, to find an angle, the cosine of question mark is equal to adjacent over hypotenuse, 32 over 35. And so, to find this angle, I'm going to use inverse cosine. Okay, and it says to round to the nearest degree, and you get 24 degrees. I'm going to put about here. Okay, and so this is a throwback to geometry. So this is actually for 4-7 and 4-8. If you do 4-7 and 4-8, you're going to be using things like this to work on your solving right triangles. So I'm either solving for a side, which we know how to do from 4-2, or solving for an angle, which we now know how to do using inverse trig ratios. For example, this one, you've got adjacent and hypotenuse again, compared to the angle. So this would be inverse cosine, adjacent and hypotenuse. This one's opposite over adjacent. So this number 8 would be inverse tangent, right? So the inverse tangent of 8 over 24, and that would give you your answer. Make sure you're in degree mode, okay? So that's all there is to this, guys, and you should be able to do 4-7 very successfully using this, and also 4-8 will come to you pretty quickly after this because we talked about it as an aside to 4-2, and also we've talked about it in this section as well. So thanks for watching, and we'll see you next time.